Welcome back, Algebra class. Today we're going to be going over Chapter 13, Lesson 8 in Jacob's Elementary Algebra. And this chapter is this lesson is one that's going to have just basically a bunch of review concepts and kind of gives you some new perspective on them and a couple new terms, but it's not really anything, you're not learning to do any type of problem that you haven't before. It's basically just making observations. So, this is review, but it's all in this lesson. We have two types of equations we've worked with in terms of graphing. And the first one is a linear equation, which is a first degree equation. What do we mean by a first degree equation? We mean that the highest power of any variable is going to be 1. So here we've got x to the power of 1 and nothing higher. And this is set in standard form, meaning it's in descending order of power. Almost it's set in standard, no, it isn't standard form. What am I saying? I wrote this problem on the board previously and it wasn't in standard form, but this time I did. So anyway, we had x plus 3 equals 0. So that's x to the power of 1 plus x to the power of 0 times 3, which is 1 times 3 equals 0. So how many solutions are there for this equation? There's only one, and we can find it by subtracting 3 from both sides, and then x equals -3. So we know that, but what if we wanted to solve it by graphing? What we can do when we try to graph for a solution of what x equals is we figure out where this is going to intersect the x-axis. So the x-intercept is going to be your answer. Same for a linear or a quadratic equation. So how do we graph it? We need to set it up in our standard form for graphing, which is going to be the y equals x plus 3. So what I did is I just changed the 0 to a y, and that actually works because if you think about it, when you're trying to find an x value as your answer, then you need your y to equal 0 because it's not even in the equation. So this equals 0, and y is going to equal 0 because it's not part of the original equation. So it makes sense. Now a linear equation is, probably goes without saying, going to be a line. It's linear. So we'll graph this, and we know that our y-intercept is a good point to start with, which is going to be if x equaled 0, y would equal 3. That's x and y at the top if you have any trouble reading that. X is 0, y is 3. Let's say x is -1. Then that would be -1 plus 3, y would be 2. Let's say x is -2. Then -2 plus 3 is +1. And let's say that it's -3. This is going to be our answer because the point where y equals 0 is your x-intercept. Just like the point where x equals 0 is your y-intercept. So here's our line, and the answer is right here. It's going to be the coordinate -3, 0. So in other words, x is -3, y is 0, because it's not part of the original equation. So a linear equation is only going to have one answer because it's only going to cross the x-axis in one place, and it's always going to have one answer because, think about it, if you have an infinite line, then no matter how far your y-intercept or any other point is from the x-axis, like if you have an infinite line and it's curved, and both of those are going to be the definition of a linear equation, then it's going to cross the x-axis at some point, right? And only once. Now we're going to compare that to these three quadratic equations. And there's a term which I've shown you before. Never actually written it on the board, I don't think, so here's how you spell it. Parabola. So a parabola is the shape of a quadratic equation. It's basically like a U, and I've pointed out that it's bilaterally symmetrical, meaning that if you found the middle point and you flipped it over on itself, it would be a mirror image. So this one doesn't really look like it has a clear center, but let's just pretend the center is off a little bit. Then if that's the center, then this side will be exactly symmetrical to that side. And I pointed out in past lesson videos that a parabola will have two answers, and that was a little bit of an oversimplification. We did actually encounter a problem where our quadratic equation only had one answer. It is actually possible for quadratic equations to have no answer. And so linears have to have one, but quadratics can have either 1, 2, or 0. The more common, I would imagine, is 2. And most of the problems we've done, there have been two possible answers. So it's a little harder, I think, to get an answer, or one with just one answer or 0 answers. But we're going to talk about how those work. In fact, these three quadratic equations are going to be an example of one that has two answers, one that has one answer, and one that has no answers. So let's graph them. First of all, they are in standard form. So in order to graph them, all we have to do is change that 0 for a y. And I really could just erase the 0 and put a y there, but I'm going to go ahead and do it this way. I'm just going to do like an arrow, because I don't really have a lot of space there. Normally I would do this underneath, as you know. And I'm just going to rewrite it. Y equals x squared plus 2x minus 3. So this is going to be our graphable version. Maybe I'll underline it. Next one, same thing, just replace the 0 with a y. Y equals x squared. Oops. Not x to the fourth, thankfully. Y equals x squared minus 4x plus 4. And finally, change that 0 to a y. Y equals, again, I'm doing this just because I'm setting it up to graph. And what are the answers for these three equations going to be? They're going to be the points where it crosses the y-intercept, or the x-axis. It's going to be the x-intercept, or intercepts, that are the answers. All right, let's start with the top one, equation A. And so equation A is going to, you know what, that's not really centered with, like you can't see the whole y-axis up there, so I'm going to make it a little lower. How's that? Yeah, it looks good. So here will be, we don't need this linear equation anymore. Here's where we'll plot our x and y values in order to graph these. All right, we'll start with 0. And if x equals 0, we have our y-intercept, which is going to be negative 3. 0 squared plus 2 times 0 is all 0, minus 3 is negative 3. So y-intercept, always a good, easy starting point. Let's say that x equals positive 1. So y equals 1 times 1, which is 1, plus 2 times 1, which is 3. Okay, so we've already got an answer, because everywhere that y equals 0 is going to be an answer to our equation. So x equaling 1 is one of the answers. So x equals 1, y equals 0. Now let's try negative 1. All right, so negative 1 squared is positive 1. 2 times negative 1 is negative 2. So 1 minus 2 is... I'm probably going to be kind of slow computing anything, even easy stuff, because I did not sleep well and it's currently very early in the morning. So anyway, 1 minus 2 is negative 1, so bear with me. Minus 3 is negative 4. All right. 1, 2, 3, 4. Okay, so I'm starting to see something that gives me a little bit of a shape. Wait, hold on a second, that's not right. Lord help me. All right, negative 1, negative 4. I was like, oh my gosh, that's a really steep curve, and that's not one of the answers I remembered. All right, so now let's do negative 2. So negative 2 squared, you got to square the whole thing, by the way. Whenever you have a negative, remember that you're inserting it, your x values, in imaginary parentheses, or actual parentheses if you're really writing this out. So negative 2 squared is positive 4, plus 2 times negative 2, which is negative 4, so that's 0, minus 3 is going to be negative 3. Okay, so we found something interesting here. Remember, the parabola is going to be bilaterally symmetrical, and that means it's going to have like kind of a lowest point. Do you think we found our lowest point? Probably, because it's going down and then it's coming back up. So yes, we found our lowest point. Now let's try the next one, negative 3. I know this is kind of a tedious process. You can always put this on double speed if you prefer. Negative 3 squared, that's going to be 9 plus 2 times negative 3. So 9 minus 6 minus 3. I think we have another answer. Yep, so 9 minus 6 is 3 minus 3. So then we have, so at this point we can kind of just continue our parabola. It's going to look something like that, and our answers are the two x-intercepts. So this is a quadratic equation that has two answers, which are 1 and negative 3, because it intersects the x-axis twice. So I'm going to go ahead and just write that answer, which is 1 or negative 3. So that's the answer for this first one, A. Now let's look at the second one. Oops, I don't need to do that yet. All right. So the second one, the y-intercept is going to be 4, because if 0 is the value of x, 0 squared minus 0 plus 4. So don't even need to compute that. You can just always know that anything not attached to x, a constant, is going to be your y-intercept. All right, so let's do x equals 1. So 1 squared is 1, minus 4 times 1 is 4. So 1 minus 4 is negative 3, plus 4 is 1. So 1, 1. All right, so it seems like this parabola is going to be oriented a little bit to the right. Let's try 2. All right, so 2 squared minus 4 times 2 is going to be minus 8. So 4 minus 8 is negative 4 plus 4. Yep, we got an answer. All right, and now that's going to be our only answer if the parabola goes right back up from here. If it continues to go down, if it goes below the x-axis, then that means it's going to come back up again, and we're going to have a second x answer. But let's see if it does. Let's try 3. So 3 squared is 9, minus 4 times 3 is 12. So 9 minus 12 is negative 3, plus 4 is 1. So because of just the geometry of a parabola, just because of the shape of it, we know that once it goes up again, it's not going to go back down. So that means this is the only answer, and it's going to just intersect right there. Now, so we've only got one answer, and we're done. Now, what if this had been y equals x squared minus 4x plus 3? Then that means that the y-intercept would be 1 lower, and the entire thing would shift down. Then we would actually have two answers, because this one here would be on the 0, and this one would be on the 0, and this one would be on the negative 1. So if the y-intercept were 1 lower, the entire thing would shift down, and you'd have two answers, not one. But because of its exact placement, where its lowest point is going to be on the x-axis, that's the only way that you can have a one-answer quadratic equation. So that's why it doesn't happen as often. All right, so this is a one answer, and the answer is x equals 0. You know, I should really say x equals here. So you may have figured out that since we're talking about the three possible outcomes for a quadratic equation, if this one is 2 answers, this one is 1 answer, let's see if this one has 0 answers, which, yes, it will. And how do we determine that it has 0 answers? I mean, you can plot points forever and just be like, okay, I'm not sure, is it going to have an answer that, you know, is it going to have a place that crosses the x-axis? You don't have to really do that, because you can just, again, look at the shape of the parabola. There's a certain point where it reaches the bottom and then goes back up, and once you do that, you've seen the bottom reaches of the parabola, and then you can figure out from there whether it's going to have 1, 2, or 3 answers, or 1, 2, or 0 answers. So that's all we have to discover. We just have to discover the kind of the trough or lowest point of the parabola to determine if we need to keep going to find an answer or not. All right, so we'll start with 0, and that's going to be 5. 0 squared is 0, plus 3 times 0 is 0, 0 plus 0 plus 5 is 5. We'll try 1. 1 squared is 1, plus 3 times 1 is 3, so 1 plus 3 is 4, plus 5 is 9. Okay, so getting a little bit of an idea of the shape. So that means that we're probably going to need to come down to try to find the lower reaches of this. So let's go, instead of from 1 to 2, oops, let's go to -1. Let's explore the left side. So -1, so -1 squared is 1, plus 3 times -1 is -3, so 1 minus 3 is -2, plus 5 is 3. All right, getting closer. Let's see at what point it's going to curve back up. -2 squared is going to be 4, plus 3 times -2. So 4 minus 6 is -2, and then plus 5, so it's going to be 3. So interestingly enough, let me pause for a second and just double check my math. I'm second guessing myself because I'm tired. I was right. So it's going to start coming back up. And now a parabola isn't going to have a flat bottom, so it's not going to be like that. What it means is that somewhere in between -1 and -2, like maybe -1.5 is probably a good guess. There's going to be the trough. So just for the heck of it, let's try this out. So -1.5, we don't really need to do this because we've already discerned that the parabola is starting to come back up. But just to flesh out the idea, what's -1.5 squared? Five times 5 is 25. What is that, 225? Yep. Move my decimals over. So 2.25, that's the actual probably midpoint of this parabola. So at -1.5, 1, 2 and a half. Sorry, and a quarter. Close enough to a quarter. So that's going to be my real midpoint. It's somewhere between -1 and -2, and I'm going to guess that it's exactly this point because it looks about right, first of all, and secondly because it's halfway in between -1 and -2. So am I 100% sure that's the exact lowest point? No, but I think it probably is. Does it actually matter for this equation? No, because we've figured out the shape of the parabola. Once you've gone down and back up, you have the shape of the parabola figured out. And the real question again is, does it cross the x-axis once, twice, or never? We can tell very clearly but this one never crosses it. So are there any answers? There are none. This is a parabola that never crosses the x-axis, and therefore it is a quadratic equation that does not have any answers. Next thing we're going to do, and I'll pause the video for this just to save the time of erasing and writing, is we're going to see what happens when we actually try to solve these three quadratic equations using not graphing, but the quadratic formula. I've cleared the board of everything we don't need, and I've gone ahead and written out the quadratic formula, and aka quadratic equation, however you want to say that. And go ahead and do yourself a favor and just like pause the video and see if you can write this from memory, because if you can, that may help you a lot on the exam. Remember, there are several different ways to solve quadratic equations. Graphing is among the slower ones, but at least, you know, that's something that you've known how to do for a long time. So for the test, you know, if you can do it fast, you'll be okay by graphing, but that's a little bit more of a stressful way to do it. The quadratic formula, a lot of the time, is really the easiest way. You know, you can do the factoring, you can do the completing the square. Those are a bit of a pain sometimes. Sometimes they work really well, but if you can do the quadratic equation or quadratic formula, however you want to say that, it's a really good one-size-fits-all way to solve these. And you can go back to my previous lesson where I go over the quadratic formula if you want a refresher, but we're going to do it enough here that you probably don't need to. So what is this part that I've outlined in red? This is called the discriminant, and I'll explain why through example, but your kind of primer for this is that the discriminant is the part of the quadratic formula that's going to determine whether your quadratic equation has 1, 2, or 0 answers. So now we're going to test these out and see if we get the same answers with them, and of course we will. But pay attention to what's happening in the discriminant as we determine whether or not we're getting 1, 2, or 0 answers. I'll go ahead and copy this again, good for practice. X equals negative b plus or minus the square root of b squared minus 4ac. And now we're going to do the quadratic equation A to do this. It's already in standard form, so what that means, since it's already in standard form, the value of x is going to be your A value, or the coefficient of x, I mean. So A is 1, because you have 1 x squared, an imaginary 1. What about our B value? That's going to be our next power. So that's why we said it in standard form. Power of 2, power of 1, power of 0 in terms of x. And then, so x to the power of 1 has a coefficient of 2, so B equals 2. And then negative 3 is left over, so C equals negative 3. All right. Now, we'll plug those in. X equals, now negative b, so we're going to say negative parentheses what our b value is, which is 2, plus or minus square root of b is 2 squared minus 4, a is 1, c is negative 3. Can you see all that? Yeah, it's tight, but hopefully you can see that. All right, so now what do? We're going to solve inside the radical. Treat that like parentheses for now. Oh, all of this, I'm so sorry, I forgot about something very important. Over 2a. Yeah, that's kind of important. Over 2, and then a is 1. All right? So, x equals, let's do some stuff in the radical. And I'm going to do this meticulously and slowly, not taking any shortcuts for your benefit. So, speed up the video if you need to. We're going to drop parentheses when we can. So we don't need them there. Plus or minus, and then we'll do in the discriminant. 2 squared is 4, minus 4 times 1 times 3, negative 3. But actually, if I have a minus and it's going to be a negative number, I'm just going to make it a plus now and turn the negative 3 to a positive. Plus 4 times 1 times 3. All of that over 2 times 1, which, yes, it's tedious, but I'm just going to keep it there. I'm just going to keep it as 2 times 1. X equals negative 2 plus or minus the square root of, all right, what do we do next in PEMDAS? Do we do addition, subtraction, or do we do multiplication? We do multiplication. So 4 times 1 times 3 is 12. over 2a. All right. I've run out of space as far as the camera is concerned, so you know what? Maybe I don't want to redraw this, so I'm just going to point the camera down. Hopefully that won't cause too much trouble. All right. And now I'll teach from down here. X equals -2 plus or minus the square root of 16. That's a promising number, right? For finding in the radical. And then over, I'm going to go ahead and deal with this now. 2 times 1 is 2. Finally, x equals -2 plus or minus 4, all that over 2. All right, so at this point, would it actually make sense if I were to say instead of that, -2 over 2 plus 4 over 2, plus or minus 4 over 2? Yes, I actually could, because when you're adding fractions over the same, oh, I'm going to take this up again. There we go. When you're adding things in the numerator over the same denominator, you can actually separate them. Like, so I'll draw this up again at the top. So my answer was x equals -2 plus 4 over 2, sorry, plus or minus 4 over 2. But I could actually instead say -2 over 2 plus or minus 4 over 2. And now I can simplify. -2 over 2 is 1, -1, plus or minus 2. All right? So that's my answer, is -1, x equals -1 plus or minus 2. So if it's -1 plus 2, that equals 1. If it's -1 minus 2, that equals -3. Did I get the same answer? Yes. And let's pay attention to what's happening in the discriminant. If your discriminant, in other words, the -4ac is going to equal something like 16, where it's going to give you like just a normal answer. In this case, a very convenient one, 4. But if it's going to give you some kind of a positive, like, real number answer, then this equation is going to have 2 possible answers. So again, anything that's like a positive answer in the box will give you a quadratic equation with, in the radical, that is, in the discriminant area, is going to give you a quadratic equation with 2 possible answers. Any guesses, as I clear the board, what type of answer in the discriminant is going to give you just a 1-answer quadratic equation? Think about this. What's the part of this that actually gives you 2 answers? It's the fact that you have a plus or minus. So you need a this or that as your answer. So what if this is plus or minus 0? Then you would only have one option, because plus 0 is the same as minus 0. So if our discriminant gives us the square root of 0, then that's going to be how we end up getting a quadratic equation with 1 answer. So let's try this out. See if that happens with number 2. All right, so what is our a value for number 2? It's going to be the coefficient of x squared, which is 1. Our b value is the coefficient of x, which is -4. And our c value is going to be the constant, 4. Always set it in standard form, so descending order of power, so that you know what your a, b, and c are. All right, we'll plug in some values. I'll try to write smaller this time, hopefully not too small for you to see. X equals negative and b is -4. Remember your parentheses. I'll do this one a little faster than the last one. Square root of -4 squared minus 4 times a times, what is c, +4. All right. So, all that over 2a. Next line, x equals, I'm going to simplify that. I don't really want that. X equals 4, and drop my parentheses, plus or minus the square root of -4 squared is 16. You see what's going to happen? Yep, you're going to get a 0 in the discriminant. It's going to be the square root of 0. So minus 4 times 1 times 4, which will be 16, over 2 times 1. Next we're going to do that part in the discriminant. So x equals 4 plus or minus the square root of 16 minus 16 over 2 times 1. All right, running low on space, but I think we can pull this off. X equals 4 plus or minus the square root of 0 over 2. All right, I'm just going to use an arrow and continue over here. All right, so then that gives us, if we want to write it this way, we could say x equals 4 over 2 plus or minus 0 over 2. Now, is 0 over 2 a paradox? No, I can have 0 unicorns being eaten by 2 people, and that leaves me with 0 unicorns. That makes sense. I'm going to carry this over a little bit. 4 over 2, yes, we can simplify this. So what we really end up with is x equals 4 over 2, which is 2, plus or minus 0, which is the same thing as x equals 2. And you can't really see that, but I wrote x equals 2. Let me double check my math real quick. So back earlier in the video, when we solved this middle equation, and what we actually got was that x equaled 2 and y equaled 0. So we got the right answer, but I accidentally wrote x equals 0. That's not what I meant. I meant x equaled 2 and y equals 0. So sorry about that. Hopefully you caught that earlier in the video. But everything we did when we graphed it in order to get the answer, it was correct. I simply wrote the wrong answer right here. So anyway, yeah, this checks out. Now we're going to try the third one. And what we should observe is in the discriminant, we're going to find that it's telling us to get the square root of something that doesn't make sense. It'll tell us to get the square root of a negative number. So if your quadratic equation is a normal one with 2 possible answers, and you're going to have a positive square root answer to your discriminant, and if it's going to have only 1 possible answer, then your discriminant will result in finding the square root of 0, which won't change your problem, and that's why you only have 1 answer, because plus or minus 0 is the same as just leaving it alone. And if your discriminant results in a paradoxical number, like a negative, then that means that there's no possible answer. There's no possible value x that would satisfy the equation, or in the case of graphing, across the x axis. All right. Now let's plug in our values here. We're kind of short on space, but I think I can make this visible. A equals 1. Yeah, okay, you can kind of see that. B equals 3. C equals 5. All right. Negative B is going to be negative 3 plus or minus the square root of b squared, which is 3 squared, minus 4, and then A is 1, as usual, and C is 5. All right, so I can already tell this is going to be a negative discriminant. So that's going to confirm that this is going to be a problem that doesn't have any answers. All over 2a, and a is 1. So continue this. X equals negative 3 plus or minus the square root of 9 minus 4 times 1 times 5 all over 2 times 1. X equals negative 3 plus or minus the square root of what's 4 times 1 times 5? That's going to be 20. So 9 minus 20 over 2 times 1. X equals negative 3 plus or minus the square root of 9 minus 20 is 11 all over 2 times 1. I'm just going to go ahead and say 2 right now. All right, so we got a problem right now. Because this is going to break down to x equals, and if I wanted to separate these into 2 fractions being added / subtracted, then this whole thing will become x equals negative 3 halves plus or minus the square root of negative 11 over 2, which you can't really see me writing on the board, but you heard me. Now, what's the square root of negative 11? it's a paradox. You can't have the square root of a negative number because a square root, again, is saying what times itself equals this number. Is there anything times itself that equals negative 11? No, because any two positive numbers multiplied by each other are going to be positive, and any negative number multiplied by itself too is going to be positive. So you can't have a negative number in the radical and have a sensible answer. Therefore, if your discriminant has a negative number that you're trying to find the square root of, there's going to be no solution. So that's why the answer to this equation is there is none. X is not applicable. So what have we learned today? We have reviewed that you can solve your quadratic formulas more than one way. And two ways are quadratic equations more than one way. One way is by the quadratic formula, which we just did. Another way is the earlier way we did, which is graphing. We also reviewed that if you have a linear equation, meaning a first degree one, where the highest power of x is 1, then it's going to be a straight line, yeah, it's just going to be a line, so we call it a linear equation. And it'll always cross the x-axis exactly one time, meaning it has exactly one answer. For x equals such and such will be the solution of the equation. And we've determined by fairly exhaustive proofs that quadratic equations can either have one answer, two answers, or zero answers. And the more common is two answers. And you can tell really quickly by looking at the quadratic formula for your equation if your discriminant is going to have you find the square root of a number that ends up being a positive number, then your equation will have two answers. If under the radical instead your discriminant is going to give you a value of 0, you're going to have one answer. And if it's going to give you a negative number that's a paradox, you'll have 0 answers. So I hope this video helped. Feel free to let me know how I can improve these, and study hard. I will see you next time.